Hello everyone, my name is Muhammad Iqbal Habibie from Indonesia.
Hello, my name is HAIDAR and I'm from Indonesia.
Hi guys, my name is SHABRINA SALSABILA and I'm from Indonesia.
Hello, my name is ABDULLAH. SHEBANI. I am 19 years old and I'm from Libya.
Alright, for program 1, so I'll explain you a little bit. So here we have the data, we have the text that we want to display, to perhaps put input or maybe to display the results. From text 1 to text 6, we have the 0 here means that we don't have to skip to the next line. Here in text 5 and text 6 you can see there is 0DH and 0AH before the text. For example here parameter for hexagon 2 its height equals. Now this 0DH and 0AH makes it move to the next line. Side hex 1, side hex 2 to store the value of the sides for each hexagon. Same here for perimeter. And finally the total perimeter, which is the total of the 2 hexagon perimeters. So here we go, let's go on to the code. We have call clear screen. I'll run it as we go so that you can understand it. Okay, so first of all we have call clear screen. This is from the library Irwin32. Now this clears the screen, so pretty much if you have text in your console here, which is this thing, it will clear it. So that's called move EDX offset text 1. So EDX is where we can hold the text of one that we want to display. So here actually we don't actually store the text itself. Here we have move EDX offset text 1. So it's not just text 1. So what is this offset? Now offset in assembly language is like the address. This is actually the address of text 1. So what you see here is the address of this variable. The next thing we have is call write string. Now call write string is a function. So here call write string is actually, you can display the text in EDX, but in EDX it's only the address, so you point to it. The EDX is a pointer for what text you want to display. So if I press continue here, it will display text 1. Enter a side value for hexagon 1. So here we have the next function, which is called with integer. So here we prompt the user to input value into EAX, into the register EAX. So for this, because we use with int, which is integer, the input will be in signed integer format. I've given comments too, so we can understand more easily. Okay, let me call the function. So now the console prompts us to enter a value of the side for hexagon 1. So for example here we have 10, because it's easier to count 10 times 6, which is because hexagon have 6 sides, should be 60. So let me enter that value first. So here we have the next line, which is move side hex 1 EX. So here we move the value that is in EX. Here we are prompted to move the value of EX to side hex 1, because we need to store side hex 1 to store the side of the first hexagon. So here at the bottom left, you see in watch 1, side hex is now 10. So the next one, which is move ECX6 in the previous lab. This is also used, which is setting a counter for the loop. So as you see in the top right, here the ECX is now set to 6. So after we have L1 colon, which is the label, and then add perimeter hexagon 1 with EX, which means to add the value of EX to perimeter hexagon 1. And we add it 6 times with the loop, and if you take a look at the top right, there's also the counter. So here's already 6 times. Bottom left, watch 1 is perimeter hexagon 1 is now 60, which is the total. Top right, the counter is at 1, but this is the final one, showing that it goes to the next line. So, and then the second wave here is the exact same code as the top. From line 18 to line 26, this is the exact same. This is because we need to count 2 hexagons. So now, as before, it shows the text, and then we need to enter another one, let's say 6, because it's also easy to count, or maybe 5. 5 is easier to count, which means 5 times 6 should be 30. We go back to the debugging, and then move side hex to EX. We store the side value into side hex 2. As you see in the bottom left on the watch, we have 5 on side hex 2. We set the ECX and the counter back to 6, again until 6 times, until 30. After that, it goes. So it will be continued by my partner. Thank you very much.
So I'll continue after my partner explain how the user input the value of set hexagon 1 and set hexagon 2 until we got the value of parameter hexagon 1, which is 60, and the value of parameter hexagon 2 is 30. To continue, we move the value of set hex 1 to register EAX. So we step into, so EAX will store 10. Then we move the text in text 3 to EDX. We step into, this will display in the program the string of text 3. So we step into, we call write in. This is to display the value of set hex 1 in the program. So we step into, the program will display plus 10. This is the value of parameter for hexagon 1. After that, we move the value of parameter hexagon 1 to register EAX. So we step into again. So EX will store 60. After that, we move the text in text 4 to EDX. We step into, then we call write string for displaying the program. As we can see, the string has been displayed. We call write in for displaying the value of parameter hexagon 1, which will be inside integer format. So we step into again. So parameter for hexagon 1 with size 10 is 60. And we move the value of set hex 2 to register EX. This we do the same as before. Then we step into again. We move the text in text 5 to EDX. We step into again. We call write string for displaying the text in the program. So we step into, we call write in to display the value of set hex 2 in the program, and the value will be inside integer format. We step into, as you can see in the program, will display plus 5. After that, we move the value of parameter hexagon 2 to register EAX. After that, we move the text 4 to EDX to display the text in the program. We step into, we call write string, then we step into again, we call write in for displaying the value of parameter hexagon 2 in the program, and the value will be inside integer format also. So we step into, as you can see, parameter for hexagon 2 with size 5 is 30. And for the last step, we add the parameter of hexagon 1 with the value of parameter hexagon 2 in EAX. We step into, so EAX will be 90. We got this value from 60 plus 30, which is equal to 90. So then we move the text in text 6 to EDX. We step into again, we call write string for displaying the text. We step into again, we call write in for displaying the value of both hexagon parameter. So in the final program, we have the total parameter is 90. Okay, that's all from me, and thank you.
Well, that is for the program. So for the output, we will see that one, which is the multiplication and divisions. And for the code, we can look. This is our code for program 2. And yeah, there are a lot because our group member also add some division 1. So not only the multiplication but also the division. So we will try to debugger. And yeah, first we can see the beginning. We do the move EDX and move the text in the EDX. Then we go, this is for display the text. Then also prompt the user to input value in AIX. So in here we can see the output is, what operation do you want to do? I will choose the multiplication. They will go to the, because multiplication is number 1, so the number is 1. Then please enter the multiplicand. So I will choose number 6. So the EX will be 6. That means the multiplier. So I will choose 7. From there we know the multiplier will be 7 in the EX. Then move the value to multiplicand to EX. We can see if the multiplicand is 6 and multiplier is 7. Then we can see if the EX begin to 6 and move the value to multiplier to EX. Then we try to move the text in text 5 to EDX. After that we will get the multiplicand R6. The multiplicand, then move the text in text 6 to EDX. And then we can go to, wait a second. Yeah, there it is. So there we can see the multiplication is 6 times 7. The product is 42. So they're asked again, what do you want to do another operations? And I say yes, 1. So we go to the to the other multiplication. So that we'll go to the main code again, the first code to the begin. Then we can see what operation do you want to do, and I will choose 0, that means divisions. Then go to the code of divisions that is similar with multiplication, but there are also the definite. As we can see, we can also so we can do the divisions, and we enter the dividend is 0 and the divisor is 3. So the division is 0 with 3, and 9 with 3 is 3, with the remainder are 0. So that's all from me, and thank you.
With program 3, so I'll explain briefly. Program 3 is pretty much the combination of implementations of program 1 and program 2. So here are the texts in text 1 until text 4. This is the array for the hello, and then this is the counter. The counter is used to count how many input is inserted, and then divisor is to determine which one to be put in the odd and which one to be put in even. And then here is count odd, where we accumulate the input for count odd, and this one is also like count odd, which is count even. And then we put the total of the count to total odd, total even, and then we add both of them to total all. So the first one is called clear screen, like before. And then we set counter to 6 because there is 6 integers, 6 inputs that we need. And then we set ABX to 0 because we want to use EBX as the array index. So as you see on the top right, we can see these two things will be changed, EBX 0 and ECX 6. Here first we add counter 1, so the first number. And then we put the text in, display, and also we want the input. So the first number, for example, here is 10. And then move hello EBX plus EBX. This is the index. So this one, the first one should be hello plus 0, or hello only. And move the value of the input to this array element. And then we go to here, move EX, move counter to EX, and then divide that with 2, which is the divisor. Here we set the EDX to 0 as before, or if there is no remainder, we jump to odd. So again, move the value of the array into it, count even, we add that, and then EXM as the next one. Then we jump to the next one. Should be explained by my teammate. Please continue.
From line 39 here, where you can see a label for a jump named odd. In this label, what we do is that we first move the value of hello, the array hello, with index EBX to the register index EAX to our count odd here, which is for a jump named next. In this label, we add the value of 4 to the register EBX. That's the reason we add 4 is because the array that we're using here is type word. D words are. We then have a loop here for the label count that we have in line 23. So moving on, we have line 47. We move the value that we stored in count even to the register EAX, and then from the register EAX we move that value to total even. We do the same thing for count odd. We move count odd to EAX, and then from EAX to total even, or we store it there. Then we have our text 2 here. We move our text 2 from the text that we stored in text 2 to the register EDX. We display that text, and then we display the value of EAX. Now we stored the value of EAX, which is a total odd. We do the same thing for total even. We move it to EAX. We display the text we stored in text 3. After we move it, we move it first to EDX, and then we display the value of total even. This is our answer here for the extra challenge, where we add total odd and total even together. So as you can see here, EAX is already total even, so we add total odd together, and then we move EAX to our total all. We display the message and the value of it. Okay, so let's run this program. As you can see here, there are the same answers. Total odd is 123, total even is 208, and we have the total all, which is the addition between those two, which is 331.
Now we must sum up what we have learned in this lab session. We know how to link to the library of the Irvin 32. We use functions or procedures such as clear screen, write, and also read. First program we use the loop with only the write and read. The second one we use the jump with implementation from the library. And finally, in the third program we use both jump and loops in the implementation. Hopefully this will be useful again in the future. Thank you very much for watching our demonstration, and we'll see you in another video.